Hey everyone, so I believe this is assignment 30 in our Trig Identities and Solving unit. Yep, verifying day 2. Okay, so I hope if it hadn't come together yet, that it all comes together now and that you're feeling a lot more comfortable. Here's our first problem. Cosecant theta minus sine theta equals cotangent theta times cosine theta. Okay, give it a try. Pause the video, give it a try. You should really do that with each of these today. Okay, well, first question, did you turn this into this, or did you turn this into this? I'm going to work the left side, but let me know if you ever need me to do a problem by working the right side. So here, I got two terms, and here I have one. And so in my mind, it's easier to take two terms and turn them into one. If I rewrite cosecant as, if I rewrite cosecant as 1 over sine, I recognize that the way for me to get these two terms to be one term is if I make a common denominator. So I'm going to multiply by sine over sine. Well, where does that take me? Sine times sine is sine squared. I have 1 minus sine squared over sine theta. And what's 1 minus sine squared? Well, that's cosine squared over sine theta. Now, this is another one of those sort of maybe you want to have this strategy on, but I think it's actually one of the ones we talked about 2 videos ago, where I'm just going to break this up a little bit. I'm going to turn cosine squared into cosine times cosine, and I'm going to take this sine and not write it like that. Instead, I'm going to write like that, because now I see that and I see that. And just sliding that sine a little bit to the left is all people need to say, oh, well, cosine over sine, that's cotangent, times cosine. And that's exactly where I want to be. So I'm all done. Okay, so what did we do? We made a common denominator. We took these two terms and turned them into one term. But, you know, we did have to break this cosine squared into a cosine over here and a cosine over here and use the sine with one of them. Many students say, well, why don't I take this and break it into 1 minus sine squared? Well, I was just there. And that's where I'm coming from. So really what I think I need to do is take cosine squared and turn it into cosine times cosine. Okay? All right, how about this one? Sine x plus cosine x times cotangent x equals cosecant x. Okay, give it a try. Hey, welcome back. You know, I think it helps people to rewrite this in terms of sines and cosines. We've got sine x times cosine x over sine x. And again, I only see one thing over here, and that's cosecant, not cosecant with a squared anywhere. So if I've got one term here, but I have two terms here, I really think I want to make a common denominator and combine those into one. So this gets a sine over a sine. So now what do I have? I've got sine squared plus cosine squared over the common denominator of sine. What's sine squared plus cosine squared? 1. And 1 over sine is cosecant, and I'm all done. Okay? All right. How about this one? How about cosecant squared theta over 1 plus tangent squared theta equals cotangent squared theta? Well, that's not a fraction. Could be written as a fraction, but right now that's not a fraction. That's a fraction. I wonder if there would be some way I could do something over here that would simplify it. Like, do you recognize that? 1 plus tangent squared is secant squared. Cool. Now what? Well, you know, there is a bridge from here to here that some people see, but most people have to actually turn cosecant squared into 1 over sine squared. And they turn secant squared into 1 over cosine squared. And then they say, oh look, a complex fraction. A fraction divided by a fraction, I better flip and multiply. So flip cosine squared over 1. And now I've got cosine squared over sine squared, and yep, that's cotangent squared. Okay? You know, if any of these you want to explore a different path, I think that's a great thing, either to ask in GroupMe or to ask when you're in your synchronous class time with Mr. Paz. Hey, Mr. Paz, Kukla did it this way in the video. Can you show me what would happen if I did it this other way? Okay? I mean, you should know what's going to happen because in all of these problems, 1 plus tangent squared, we're being told what our answer needs to look like. And so if I don't get to that, then I'm probably stuck somewhere. And so maybe it's worth saying to Mr. Paz, hey, Mr. Paz, Kukla did it this way, I did it this other way, but I wasn't able to close the deal and get to that thing. Can you show me how to get there? I think that would be fabulous. Or you can ask me on GroupMe. Okay, how about this one? Tangent squared theta minus sine squared theta. Where'd you go? There you are. Equals tangent squared theta times sine squared theta. Now, I don't know about you, but this wigs me out a little bit. You're saying this thing minus this thing is the same as when I multiply those two together? Yeah, it really is this. Okay, so give it a try. Hey, welcome back. So, I'm wondering, what did you do? Most students turn this into sine squared over cosine squared minus sine squared. Now, at this point, some students make a common denominator. Yeah, I really don't want to make that common denominator. You know, if we were in the room together and you said, hey, can you show me making a common denominator? Okay, I'll make cosine squared, cosine squared, and so now what? Well, we've got cosine squared on the bottom, and on top we have sine squared minus sine squared cosine squared. Okay, now what? Well, I can factor out a sine squared, and I'm left with 1 minus cosine squared over cosine squared. Okay, well, what's 1 minus cosine squared? 1 minus cosine squared is sine squared. And on the bottom, cosine squared. Now, do you see what I just did? I took this cosine squared that was in the middle, and I put it over here, because I was looking about sine squared over cosine squared is tangent squared. Or what about left justifying the cosine squared? Putting the cosine squared over there. Because now I've got tangent squared times sine squared, and that's not exactly. Okay? But that's the way I didn't want to do the problem. Well, if that's the way you didn't want to do the problem, how did you want to do the problem? Well, I saw two terms here, and both of them had a sine squared. So I wanted to factor out a sine squared, leaving me with 1 over cosine squared minus 1. Well, 1 over cosine squared is the same thing as secant squared. Secant squared minus 1. Secant squared minus 1 is one of my Pythagorean identities. It's tangent squared. I factored. I used an identity. I used another identity. I know my identities. Magic secrets of trigonometry. Know your unit circle. Oh my gosh, that's going to be so important when we're solving trig equations in the next part of this game. Draw a triangle. Haven't seen many draw a triangle problems in this unit, but we certainly saw a bunch of them in the last unit, and we're going to see more going forward. And then use your identities. I've got to use my identities, I've got to know my unit circle values, and draw a triangle. Those are my three main secrets of trigonometry. I guess in this section, maybe we'd want to add, yeah, and it really helps to know your 9 strategies too. And I agree with that statement. I think that's a very reasonable statement. Okay, so which one next? Yeah, this one. Cotangent x over cosecant x plus 1. And we want to turn that into cosecant x minus 1 over, where'd you go? Cotangent x. Okay. Give this one a try. Hey, welcome back. So I think this is a great example of something I mentioned in a couple of videos ago. Some students want to turn this into sines and cosines. And that's just going to take a lot longer. I see 2 things here, but only 1 thing here. And I see the conjugate on top. And so for me, this is all about multiplying by cosecant x minus 1 and multiplying top and bottom by the conjugate. On the bottom, I want to FOIL. On the top, I want to resist the temptation to distribute. Why? Well, let's see what happens when we FOIL on the bottom. We're going to have cosecant squared x plus cosecant minus cosecant. The middle terms go, and I have minus 1. On top, I'm still resisting temptation to distribute because what's cosecant squared minus 1? Yeah, it is. Cotangent x, cosecant x minus 1, and on the bottom, cotangent squared x. Cosecant squared minus 1 is cotangent squared. And I can cancel and cancel, and I'm done. Those people who are rewriting things in terms of sines and cosines, yeah, you should be able to get there, but it's going to be a long walk because at some point you're going to have all these things that are sines and cosines, and you're going to have to turn them back into cosecants and cotangents. Dude, I so don't want to turn these into sines and cosines only to have to turn back into cosecants and cotangents. You know, though, if that's the only way you see to do this problem, then you need to do this problem that way. But really, get comfortable with conjugate. Oh my goodness, it makes this so much easier. Okay, how about this one? Sine to the 4th theta plus 2 sine squared theta cosine squared theta plus cosine to the 4th theta equals 1. Well, you know, there are a lot of things that equal 1, so I'm not going to try and work this side and turn it into this stuff. But you know, I do see something here. What if I gave you x squared plus 2xy plus y squared? Could you factor that? Wouldn't that be x plus y, x plus y? Well, guess what? I have that same setup here, same structure here. Instead of x squared, I've got sine to the 4th. But look, this is half the power of that. This is half the power of that. This is half the power of that. That's half the power of that. I think this is going to factor as sine squared plus cosine squared and sine squared plus cosine squared. You could always do this by grouping and get there, but that's where we expect to be. And what is sine squared plus cosine squared? And what is sine squared plus cosine squared? 1 times 1 is 1, and we're all done. This is a factoring problem. Factoring is one of our strategies. Mr. Cook, I just don't know how are you doing that. Well, okay, let's have this conversation. you've got a list of strategies. I think I have my list of strategies right over here. Hold on, I'll get it. Yeah, you've got a list of strategies. And so my recommendation is that if you're stuck here, that you start at the top of your strategies list and say, rewrite in terms of sines and cosines. Well, it's already in terms of sines and cosines. Take two fractions, make a common denominator, bring them to one fraction. I don't have any fractions. Split a fraction into two separate fractions. Yeah, no, I still don't have any fractions. Factor. Factor, it's right there. Let's keep going and see if there are any others. Foil. Yeah, there's no foiling, there's no distributing. Use trig identities. Well, so here's the thing. I might be able to take this down that path, where I see this as 2 times 1 minus cosine squared theta times cosine squared theta plus cosine to the 4th theta. And what would I have to do here? Well, that's sine squared times sine squared. And so I guess I could turn that into 1 minus cosine squared times 1 minus cosine squared plus this stuff. And you know what? I think it'll work. I think we'll be able to get to 1 that way. But I'm not sure. And yeah, so 1 minus 2 cosine squared plus cosine to the 4th plus 2 minus 2 cosine squared times cosine squared plus cosine to the 4th. Well, so cosine to the 4th plus cosine to the 4th is 2 cosine to the 4th. So that one and that one I've combined. Now we have minus 2 cosine squared minus 2 cosine squared, but this is attached to that. You can't do that. You know, I can this is that plus 2 when I distribute it, and then I got that. Where's that one? Oh, where's that? That's cosine to the 4th. Okay. So I did do the, no, I haven't done distributing yet. That's the issue. This has to be distributed here. So, okay. 1. Yeah, no, not going to do it. Instead, just going to focus on the distributing. And over at the cosine to the 4th. So I'm going to have 1 minus 2 cosine squared theta plus cosine to the 4th theta plus 2 cosine squared theta minus 2 cosine to the 4th theta plus cosine to the 4th theta, and all that should equal 1. Okay. Positive cosine to the 4th, positive cosine to the 4th, minus 2 cosine to the 4th. One of them plus one of them is 2 of them, minus 2 of them, they all cancel. Okay, now what do I have? I've got 2 minus 2 cosine squared plus 2 cosine squared. They cancel. And so now it looks like I've got 1 minus 2. Oh, no, that 2 is gone. Yeah, I just have the 1. This 2 went away with 1 of these plus 1 of these, made 2 of them, minus 2 of them. And so I'm left with just that 1. Yeah, I can do that. I would much rather do it the way I did it, though. But yeah, you can use your identities here, right? Isn't that what we did? We broke this up and broke this up. We broke these up. And we did that strategy where we rewrote this into one trig function. There it is. Rewrite into one trig function by using our identities. Or we could factor, which is what I did at the beginning. Okay, so you may have to actually pull out that strategies list and slowly go through each one until you get to that place where you say, oh yeah, that's what this is. Okay. How about this one? Sine t 1 minus cosine t. And over here, we have cosecant t plus cotangent t. Okay, so here's what I can't do. Can't break this up into sine t over 1 minus sine t over cosine t. That's really, really, really bad algebra, pre-algebra. No, you can't do that. Don't do that. Please don't be that person who does that. Okay. So over here, what would I do? Well, I'm already written in sines and cosines, and I see that binomial down there. I'd probably use conjugate if I were working this side. If I'm working this side, I'm going to rewrite things in terms of sine and cosine. Cotangent is cosine over sine. And then look, I've got a common denominator, 1 plus cosine t over sine t. But guess what? I'm still going to use the conjugate. Right? I'm going to multiply here by 1 minus cosine and 1 minus cosine. How did I know that? Well, Mr. Gupta says, look where you're going. You've got a 1 minus cosine on the bottom. So I somehow have to get a 1 minus cosine. And boy, that's just the conjugate of the numerator. If I FOIL on top, I end up with 1 minus cosine squared. On the bottom, I've got sine times 1 minus cosine. Again, I'm resisting the temptation to distribute. Why? Because 1 minus cosine squared is sine squared. And so that cancels that, and now I have sine over 1 minus cosine. So I can certainly work that side. And on the left side, yeah, I'm just going straight to conjugate. Okay, FOIL on the bottom, resist the temptation to distribute on top. There are times when I need to distribute. Yeah, this is not one. I think it's almost never the case when I'm doing conjugate. 1 minus cosine squared. Well, what do we know about 1 minus cosine squared? Well, I know that 1 minus cosine squared is sine squared. And I can cancel, and now I'm all done. Okay? Really, the best thing I can suggest if you're comfortable with your identities and you're comfortable with the strategies, you just have to do all these problems. I mean, you really just need to practice them. Practice them, practice them, practice them. So, how about this one? Cosecant to the 4th theta minus cotangent to the 4th theta should somehow equal cosecant squared theta plus cotangent squared theta. All right, so why did we do pre-cal first? Because I want you to see the difference of squares. That's a difference of squares, right? You know, a squared minus b squared is going to factor a minus b plus b. Well, a to the 4th minus b to the 4th is going to be a squared minus b squared, a squared plus b squared. Look at another difference of squares. Squared thing plus squared thing, squared thing plus squared thing. This is a difference of squares. So how do I factor this? It's going to be cosecant squared theta minus cotangent squared theta times cosecant squared theta plus cotangent squared theta. Cool. What's that? Well, if I'm really comfortable with my Pythagorean identities, I know that cosecant squared minus cotangent squared is 1. And look, I'm done. Now, some people catch the factoring. And then they say, well, maybe I should turn one of these things into the other. Like, maybe I should turn these into cotangent things, because cosecant squared is 1 plus cotangent squared. Okay, 1 plus cotangent squared minus cotangent squared times, this was going to be 1 plus cotangent squared plus cotangent squared. Okay, these I get 1. Here, I get 1 plus 2 cotangent squared theta. How does this turn into? I'm not sure. 1 plus cotangent squared. Cosecant squared. 1 plus cotangent squared. Cosecant squared. But now I still have to get from here to here. Well, maybe I should write this as 1 plus cotangent squared plus cotangent squared. No, because that's getting me cosecant squared. Oh, that's what I wanted. Oh, look at that. So yeah, you can definitely do it that way. Oh my God, and those poor kids who say the first thing they want to do is turn these into sines and cosines. I mean, this approach, yeah, we could get through it. But wow, the kid who's turning this into sines and cosines, and then trying to do this, and then they've got sines and cosines, but somehow they have to go back here, so they have to rewrite things in terms of cosecants and cotangents. Oh no, no, please don't be that person. Like I said, rewriting things in terms of sines and cosines, it's so very useful when we're first learning this. But as we get to day 4, yeah, no, I don't want to. I'm not gonna. You can't make me. Okay, how about this one? Cosine beta over 1 minus sine beta should be equal to secant beta plus tangent beta. How are you going to do this one? Any thoughts? Give it a try. Pause the video, come back when you're done. Okay, so at this point, some students want to work this side and turn this into 1 over cosine plus sine over cosine. And so then they have 1 plus sine over cosine. But we want the cosine on the top and the 1 minus sine on the bottom. I'm going to use the conjugate. Okay, so here's the thing. I'm going to use the conjugate and I'm going to finish the problem. But if over here we just started with the conjugate, that might have been easy. So we've got cosine beta, resist the temptation to distribute. On the bottom, we FOIL, we get 1 minus sine squared theta. Beta. What's 1 minus sine squared? Yeah, that's cosine squared. Cosine beta, 1 plus sine beta over cosine squared beta. Look, cancel, cancel. And now that I have 1 plus sine beta over cosine beta, yeah, now I want to split this up. I want to split this into 2 fractions. 1 thing on the bottom, 2 things on the top. I can split 2 things on the bottom, 1 thing on the top. I cannot split. So right now I have 1 over cosine plus sine over cosine. Well, that's secant. And that's tangent. And I'm done. Okay? So we've got a bunch of different ways to do this problem. Again, I don't really care which way. I think, whatever way you see is the way I like it that you do it. Okay? All right. 2, 3 more? Sure. How about this one? Tangent squared x over secant x plus 1. And somehow that's supposed to be 1 minus cosine over cosine. All right. That'll be interesting. Can't wait to see what you make of that. Hey, welcome back. So, right or left, which did you work? Well, part of me wants to do conjugate here. Part of me wants to do conjugate here. Part of me wants to split this into 2 fractions. and go from there. Part of me wants to take tangent squared and turn it into secant squared minus 1. 4 very different ways to do this problem. So let's do some of them. Tangent squared is secant squared minus 1 over secant x plus 1. This is a difference of squares. This factors as secant x minus 1, secant x plus 1. The secant x plus 1's cancel. Now what do I have? Well, secant is 1 over cosine minus 1. If I make a common denominator, I've got 1 minus cosine over cosine. And I'm done. Okay? So that was turning this into this. Okay? What if we had done conjugate? Well, conjugate here is going to be secant x minus 1, secant x minus 1. Okay? Got tangent squared x, secant x minus 1, and on the bottom, when I'm done foiling, I'll get that. Now, I resisted the temptation to distribute. Why? What's secant squared minus 1? Well, secant squared minus 1 is tangent squared. And so those go. So now I've got to get rid of, like I'm looking where I'm going. I only see cosine stuff here, but on this side, I see secant. So I'm going to get rid of secant by saying 1 over cosine minus 1. And then I'm going to multiply this 1 by cosine over cosine, and that will give me 1 minus cosine over cosine, and I'll be done. Okay, that's with the working the two different ways on the left side. Now let's work on the right side. What if we used conjugate? Okay, so we're trying to make tangent squared x over secant x plus 1, and over here I'm saying, hey, what about conjugate? Could that work? Let's take a look. 1 plus cosine x over 1 plus cosine x. I'm going to FOIL on top, and I'm going to have 1 minus cosine squared x. And on the bottom, I'm going to resist the temptation to distribute. And here is sine squared x. And here is cosine x, 1 plus cosine x, or cosine x, 1 plus cosine x. Okay, well, I'm supposed to be turning this stuff here, and I want it here. Well, that looks like a problem. So, yeah, I can actually get from here to here in one step. And it's kind of like magic number 1. What I would need to do is multiply the top by, well, let me ask you. I've got sine squared over 1. I want tangent squared. What do I have to multiply sine squared over 1 by to turn into tangent squared? Well, I need to use 1 over cosine squared. You can't just multiply the top by 1 over cosine squared unless at the same time I multiply the bottom by 1 over cosine squared. So how does this help? Well, let's take a look. Now I've got sine squared over cosine squared. And on the bottom, this cancels one of those. And so on the bottom, I have 1 plus cosine over the remaining cosine. And so now I do my flip and multiply. Yeah, I think I do my flip and multiply. Something like this. That was tangent squared. Oh, that's it. There's the square. Yes, there, squared, squared. So the top can then be tangent squared, and if I flip and multiply, I get cosine x 1 plus cosine x. Great, I got the tangent squared, but somehow this has to turn into that. Blah. Now I can't split this into 2. What I have to do here is use the conjugate again. Oh my goodness, I'm not going to do that. You can do that if you like. I've done this problem 2 successful ways, so I'm going to go with 2 successful ways. That's okay with me. All right. So, do I have more? Yeah, no, not going to worry about that one. Yeah, so sine theta cosine theta plus cosine, oh, there's two different units, alpha. And this is cosine theta sine alpha, over cosine theta cosine phi minus sine theta sine phi. And all of this should end up being tangent theta plus tangent theta, 1 minus tangent theta tangent, oh, sorry, that's a phi. All right. Look, it's already rewritten in terms of sines and cosines. Yeah, you know, I've only got two terms on top, and I could factor, well, wait, these are the, oh no, they're not the same, because these are thetas, and these are phis. And I can't factor a cosine theta out of each, because only this one has cosine. Wow. Okay. And on the bottom, oh, I sure as hell don't want to do conjugate with that. Well, here's the thing. I can do this problem in one step. Ooh, and I'll show you my one step, my magic number one in a moment. But you know, you could split this up like that, and like that. That'd work. I wouldn't want to do it, but that'd work. And then I'd probably have to use conjugate at that point. Yeah, so instead, I'm going to ask this question. Because look, I see the parallel structure. Thing plus thing. Thing minus thing. Okay? So, what do I have to multiply here by in front of that plus sign? So that the phi goes away and I'm left with tangent theta. Okay, so to get tangent theta from here, I need cosine theta on the bottom. And to make cosine of phi go away, I need cosine of phi on the bottom. Because then these will cancel and this will turn into tangent theta. So what do I need to multiply by? Well, I think I need to multiply top and bottom here by 1 over cosine theta cosine phi. And I'm going to distribute that here. And so what am I going to have? I'm going to have sine theta cosine phi over cosine theta cosine phi plus, because I'm doing it to everything up there, plus cosine theta sine phi over cosine theta cosine phi. And then on the bottom, what do I have to multiply this by? So it turns into that. The answer is 1 over cosine theta cosine phi. Right? I have to multiply by some strange form of 1, something over itself. So when I multiply 1 over cosine theta cosine phi times this, I'm going to have cosine theta cosine phi over cosine theta cosine phi minus, because I'm distributing, right, this all the way over here as well, sine theta sine phi over cosine theta cosine phi. Wow. Now what? Well, funny you should mention. These are the same. These are the same. These are not the same. That's cosine phi, but these are the same. Cosine. Sorry, I think there was a mistake there. I got this on top. Cosine theta cosine phi over cosine theta, cosine phi, right? These cancel, leaving me with 1. And here, I've got sine over cosine, and that should be a phi. Okay, so sine of theta over cosine of theta, that's tangent theta. Sine phi over cosine phi is tangent phi with a minus and a 1. And up here, sine theta over cosine theta plus sine phi over cosine phi, tangent phi. One step. I do it in one step. I just have to figure out what do I multiply this by to turn into that. Or what do I multiply this by to turn into that? Okay? Magic number 1. And yes, I would be comfortable putting magic number 1 as a problem on your test or quiz, but that one, that was much harder than the one we saw before. The one we saw before, yeah, very reasonable test question. This one, wow, it's a good thing we're not honors pre-calc trig, or we'd be doing that one. Okay, so I think this is the last problem I want to look at with you. Cosecant x over 1 plus cosecant x minus cosecant x, 1 minus cosecant x, and we should end up with 2 secant squared x. Okay, I really think you should be able to do that, so give it a try, and I can't wait to see what you get. So, did you make common denominator, or did you multiply top and bottom by conjugate? It doesn't matter, they're both the same. So cosecant x, 1 plus cosecant x, no, it's 1 minus, over 1 plus cosecant x times 1 minus cosecant x. And on top we have that minus sign, and we've got cosecant x, 1 plus cosecant x. So here, I really will distribute. I'm not going to resist the temptation to distribute. I'm actually going to distribute. And so on top, I'm going to have cosecant x minus cosecant times cosecant is cosecant squared, minus cosecant times 1, minus cosecant times cosecant is minus cosecant squared, all over, and when I FOIL the bottom, I have 1 minus cosecant squared x. Okay, what do you see? Well, cosecant minus cosecant. Minus cosecant squared is going to be minus 2 cosecant squared. And on the bottom, 1 minus cosecant squared, well, that's cotangent squared. No, it isn't. It's negative cotangent squared. Okay, so let's go further. Almost there. Negative divided by negative, that goes away. 2 cosecant squared x, cotangent squared x. And look where we want to get. It's got secanty stuff. So I need to get rid of this stuff and get some secanty stuff in there. Okay, so I would think about cotangent squared being the same as cosine squared over sine squared. And I would say, if I flip and multiply, like I would rewrite this in terms of sines and cosines. I think that's for most people the fastest way. This is 1 over sine squared over cosine squared over sine squared. And so if I do the flip and multiply, 2 over sine squared times sine squared over cosine squared, I end up with 2 over cosine squared, which is 2 secant squared. Okay. Oof, that was a bunch. I hope this helps. I hope you're feeling more confident. I hope you're learning your identities. Usually by this point, the people who are engaging actually have the identities pretty solid. So keep practicing. Okay? Let us know if you have more questions. Take care.